I know this is something that we already touched on. I'm going to try to keep this as short and pain-free as possible. So hang with me while I go through these. So first of all, we have the quadratic equation. We have been working with this for a week or two now. And one way that we can find the roots and zeros of our quadratic is by using the quadratic formula. So this formula you guys are already familiar with, but kind of the main focus of today is looking at this little portion underneath the square root. So this portion is what we call the discriminant. Okay, and the discriminant tells us a lot about the roots that we're working with. So make sure somewhere in your notes that you write down this chart. So our discriminant, like I said, was the b squared minus 4ac, part of our quadratic formula. And if the result of your discriminant is positive and a perfect square, then that means that our roots or our zeros, that we are going to have two rational roots. Okay? This ultimately means that our quadratic is factorable. Okay? So if we were to look at a graph, here I'll make two. That means that your quadratic is going to have two real zeros. So if our quadratic or our parabola looks something like that, or if it looks something like this, in both of these cases, our parabola is crossing the y-intercept at two places. Okay? The second situation, if your discriminant was positive and not a perfect square, then that means that you would have two irrational roots. Okay? Ultimately, this would mean that your quadratic is not factorable. Okay? Looking at your graph, that would mean that you would have two x-intercepts, yet they would not be at solid points. So it's going to look very similar to what we just had. Yet you would not have rational points at which your parabola is crossing the y-intercept or y-axis. Okay, the next situation is if your discriminant equals 0, then that means that you're going to have one rational double root. Okay, ultimately, this means that your quadratic is factorable. But what that looks like is that you would have one x-intercept at the vertex. Okay, so if we were to draw up our graphs, you could have a situation that looks like this, where you just hit the y-axis one time, or you could also have a negative case. It looks something like this. The final situation for your discriminant is if you were to come up with a negative discriminant, that means that you would have two imaginary roots. Okay? Ultimately, that means that your quadratic is not factorable. Okay? And you are going to have no x-intercept. Okay? So if I was to draw two graphs, that would mean that you could have a positive that is above the y-axis, or you could have a negative that starts below the x-axis. All right, so I know I went through that pretty quickly. Make sure you take note of all four of the different cases for your discriminant. So an example problem for this looks something like number one, where you are going to use the discriminant, to find the nature of your roots, and then we're going to solve using the quadratic formula. So right away, we have a quadratic in standard form with our a value being 2, our b value being 1, and our c value being negative 15. So for the discriminant, we would have b squared, we'd have 1 squared minus 4ac. Okay, so just that small portion of your quadratic formula. So that gives us 1 plus 120, which ultimately gives you 121. So at this point, you need to look back at your chart, and eventually you'll have this memorized. But what does a positive discriminant mean? Okay, if we have a positive discriminant that is rational, like 121, that means that we will have two rational roots. Okay, so this tells us what our result is going to look like after we use the quadratic formula to solve for our roots. So now let's use the quadratic formula. So we've got x equals negative b, so negative 1, plus or minus the square root of b squared, which we already know right here is going to be 121, b squared minus 4ac. So we can just plug that in right away. All over 2a should be 2 times 2. So let's go ahead and simplify this. X equals negative 1 plus or minus 11 all over 4. So this is going to give us two separate cases. One case where we are adding 11 and one case where we are subtracting 11. So for us to just go back up here, our cases are x equals negative 1 plus 11 all over 4. And we have x equals negative 1 minus 11 all over 4. So in my first case here, this would give me x equals 5 halves. And in my second case here, x would equal negative 3. So those right there would be my two rational roots for my quadratic above. So let's take a look at one more example, and we will save the other two for class. So looking at number 2, let's do the same exact process. So once again, we have our a value, which is 2, our b value, which is negative 9, and our c value, which is 8. Okay, so solving for our discriminant, we have b squared, so negative 9 squared, minus 4ac. So negative 9 squared gives me 81. Negative 4 times 2 times 8 gives me negative 64, which simplifies to be 17. So 17 is not a perfect square, yet it is a positive number. So looking back at your chart, that indicates that we will have two irrational roots. So using our quadratic formula, we have x equals negative b, so negative 9, which is positive 9, plus or minus the square root of 17 all over 2a, so 2 times 2, which simplifies to be x equals 9 plus or minus 17 over 4. And since the square root of 17 is not So since 17 is not a perfect square, it's not going to simplify nicely as a radical. So we will leave it just like that, and that can count as our two different answers. You can also write your plus case and your minus case. Totally up to you. Either works for me. But by using the discriminant first, it actually speeds up our process of using the quadratic formula because we already know what our final solution for our roots is going to kind of look like. All right. So I would highly recommend try 3 and 4 on your own. If you guys try it on your own, it will save us a lot of time during class going over them. And that should be it. All right. Thanks for watching.